Hi. Hi, so my name is Agnes. I'm here to share with you some tips, tricks, and things to avoid that I've faced during my time learning reactive programming. So you don't have to go through at least the bad parts, and you can still do it every day. I'm an iOS developer at Ustream, which means I'm working on apps people use to watch and broadcast videos. It also means that we are shipping apps to millions of users, so we do our very best to maintain a stable, readable, loosely coupled code base to keep its quality high. And that is one of the reasons why we write reactive code, and the other is that because it's fun. And it actually doesn't mean that we consider reactive programming as some kind of holy grail. We are just, as probably most of you, we are mixing several paradigms on purpose, and we're using lots of different patterns that helps us keep the desired level of quality in our code. Let's see quick what reactive programming is about. This is my favorite explanation. It's a quote from Matt Gallagher from one of his brilliant writings on cocowithlove.com. He says, reactive programming manages asynchronous data flows between sources of data and components that react to that data, that need to react to that data. So I think this tells the point precisely. He discusses reactive programming in several blog posts, and make sure to check it out. There is also a framework that he's written on your own. It's called CWS Signal, and it's awesome. So let's see what you gain by solving the problem of the asynchronous data and that you need to react to it somehow with using the reactive paradigm. So I consider the most important advantage is that it helps to reduce state, meaning instead of maintaining sometimes even very complex state in our applications, which is definitely error-prone and difficult to test, we try to define the reactions to changes instead by creating different scenarios, like what you would do as a condition in the imperative word. So they are like branches of the certain data stream. The transformation and combination of these streams are made easy and powerful via certain operators like flat map, reduce, combine, filter, and so on. So you can easily turn your code declarative this way, focusing on the what, not the how. So what kind of technology can we use to write reactive code on iOS? There are plenty. There is RxSwift, there is Reactive Cocoa or Reactive Swift, and there is Bond and many, many more. There is also your own you can write yourself. I just seen a presentation about from Andre Staltz, who wrote a reactive framework at a conference as a talk. So should be easy, right? These are the frameworks I mentioned. These are all amazing projects, and quite a lot of them have great communities behind already. There are frameworks several years old to frameworks that has been written yesterday. So the differences between these frameworks are mostly about their design and the level of control you have. There are micro frameworks to use the most convenient features of the reactive paradigm. Let's say observable streams of values with these transformations and combination operators. It's already powerful. That's kind of what we do at Ustream with our own implementation. On the other end of the scale, there are the large frameworks with those, you have all the power to build up like every piece of logic or complex flow of your application reactive. In this presentation, I'm going to pick the code examples from several different frameworks on purpose, so you can see they all have the same idea behind. The point is that the concepts are similar, so you only have to learn them once, and anything on the others, in the others should seem at least familiar. So when do we use reactive programming? I've heard a very good argument about this on our team. They say under a certain level of complexity in the code, reactive makes it even more complex, but after a point, it makes complex code much simpler. And I think that is very true. I found it very true. Let's say we have picked our use case, which is probably a complex application, and picked our framework. How do we apply it in our code? So far, it seems to me that it generally works out well if we use reactive for bindings between views and view models, or when reacting to certain async operations like network requests. I say, or there is MVVM because that's what we are doing, but I could also say that the bindings between the view and the view's logic. The reason why it works well is because updating state based on asynchronous events on the UI or network operations is a classic example of complexity that reactive programming is meaning to solve. Lots of state changes of async events. The simplest and most commonly used pattern in the reactive world is observing the values that travel on the data streams we are interested in. Let's see how we can observe a certain event stream. Here you can see the word signal, which is the core concept of reactive Cocoa. It represents event streams that are observable and can populate events that are that either next values or errors or completed events or interrupted events on that stream. So when there are new values on the signal, the values travel through the signal and end up in the observing functions body. Let's see how to reduce some state with our reactive approach. So here on the left side, we have 3 flags in our, for example, class, which we intend to set based on things like callbacks of API requests or certain UI actions. When we have 3 flags, that it means they can build up 8 different states in their context, right? So 8 different combinations you can have, and you have to maintain. When we go reactive, on the right side, you can see like a dummy example of how to just derive the first value from the other 2. So for 3 flags, it only means just 4 possible states. It's already win. Now let's move to the part of just seeing how transforming or combining the streams can help reduce complexity and just simplify code. Here you can see that it's possible to merge 2 streams of data, and from that point you're operating with the elements from the combined stream. We combine 2 observables, and once both of them have a value, the combined latest is being triggered with the latest value from both. This is a certain strategy of combining streams, but the strategy that you need when combining can vary. So there are, for example, merge, where you get all the values when they are coming in, or there is switch to latest or zip. In this case, it's in RxSwift. Another powerful aspect is that when you can turn other async operations like network requests into reactive streams, so they can be handled exactly as, for example, click events of a button, and so you can combine them and you can chain these operations as well. It means you no longer need specific methods for reacting to these, like passing over completion handlers or defining IB action methods and maintaining a bunch of state for the proper behavior. So since, as I mentioned, they are practically identical streams, you can combine them with each other. Here we are combining a button click with a response of a request, basically. So you get a cat fact when you click the button, which is super handy. Now let's move to the bad part. So is there anything in the world without trade-offs? I'm not sure, but the reactive programming has its own set for sure. The number one problem, I think, so far is debugging, because your call stack is not your best friend anymore. At least it won't be able to tell you what happened that as precise as it would with a traditional imperative call stack, which is, by the way, beautiful. So how to help this? There are some tricks out there. For example, like when you're suspicious of a certain stream causing some kind of problem, then there are ways to attach console logs to the event streams in some of the frameworks. Like here, you just, it's Reactive Swift example. Yeah, so here's log events, but there's, I think it's called Debug in RxSwift. So it basically just prints out where the values of the streams and where it happened. Still, so this hint could already save you a lot of time and headache, but it's a difficulty you have to encounter. There is this phase when of learning reactive programming, at least it has happened with me, when people realize the power of observation and want to use it literally everywhere, which is fine, but just for like reducing KVO boilerplate code, I think a whole reactive framework might be a bit of an overhead, not just in size, but in performance as well. Wow. Oh, here it is. So using observation to update state manually can easily lose the point of going reactive. Here, basically, it really just replaces KVO in this case. But you can, if you are already using a reactive framework for that, you can just use bindings instead. Here we just bind the view model's title to a label, and that will update the label's text every time the view model gets the new title. So embrace bindings. If you still need those conditions, to add some conditions to your logic, you can still add them and just combine them into the reactive flow. This is an example from Bond. You can also, so you can have one-way bindings or two-way bindings, which is which comes very handy when you like to define the connection between, for example, user input and the model representation of that data. It's very nice that you're able to inject side effects to a stream. regardless of the fact that side effects are considered evil. And that is because they introduce complexity. So the more side effects something has, the more difficult it is to measure or define what's going to happen after one single change. So they are evil. But there is also another aspect to it. So there are actually different kinds of observables, like hot and cold. In the cold case, when injecting a side effect to a signal, it will perform every time there is a new subscriber to that signal. So this is fine because that is how it's designed, but what you have to make sure is that you're aware of how the implementation you're relying on it handles it. So with that in mind, just make sure to only add side effects where it's necessary. For example, when you want to add a basic tracking to your app, it makes sense to just inject them as side effects to your event streams. Just make sure your observables are of the kind you want to work with. Like here, if it's a button tap, it's supposed to be a hot signal, which makes sense to just send the analytics events when the button was actually tapped, not when someone subscribed to for this update. So I think this is the most difficult to prepare for, because once you get the feel of reactive programming, it can be very challenging to say no to it, which is indeed necessary when it comes to keeping the bugs out. I regularly found myself in situations in the past where I was trying to force reactive behavior onto some piece of code unnecessarily, which is a lot of time, and it's really not always useful. So this would be just a basic example of causing nice synchronization issues. Here we update the mutable items from different threads, which is very easy to do also without any reactive. But I think it's easier to fall into this trap this way, since when subscribing, you have no idea where this event is coming from, at least not from the surroundings of the code. And of course, this behavior might lead to unexpected results. So it's easily fixable, though, by generally designing your state to be immutable. So, for example, returning new sets of items, in this case, instead of modifying it, and by using schedulers to be in control of where the work is getting done, you can make sure that to avoid these kind of situations. So the other thing is when there is a very, very complicated network of logic behind sometimes just one little switch. So this is pretty cool, but I think it's better to try keeping it simple. Otherwise, the effect of one change is going to be more than a person can just keep in mind all the time. Not to mention newcomers to the code who can't even see where the events are coming from without understanding like more layers of the application. So as you can see, the promise of reactive programming does not imply you have to give up solving something the traditional or imperative way when it makes more sense or just simpler. I think it's very important to keep in mind, especially because we all depend on a massive set of code, like the Apple frameworks, that's mostly designed for traditional usage, which sometimes can be quite complicated to bridge to the reactive world. Speaking of, when you're composing your APIs yourself, it's nice to keep the reactive philosophy out of it, so you don't force it on others. What you might want to consider, though, is to make sure your APIs support it. You can do it by making sure your properties on your interfaces are observable, for example. And thanks. That was Everyday Reactive. If you have any questions, just ask me right after my talk or ping me on Twitter anytime. This is my handle out there. And I've collected some resources and reactive frameworks for you. So enjoy and thank you.
One question. How have you found onboarding new developers into a project when using one of the reactive frameworks?
How do I?
How have you found new developers coming on board on a project? Have you run into problems with that? Or have you found it an easy process and people just pick up the new technology fairly well?
So sorry. So I think it has been difficult in the past because when someone never seen reactive code before in their life, I think it's quite not easy to learn. But I think they can catch up with it if they are actually working with a reactive code base every day. So I think it's slower than just getting to know a new code base, but it's not that bad. And what I found recently is that there is like a trend in the community of trying out reactive and people giving talks on it. So in the past year, actually, all the candidates at our team, for example, whom I talked to with on the interviews, they were all aware of reactive programming. They all tried out, at least on pet projects. So from that point, it's not much of a difference.
Out of all the libraries you've listed, like which one does your company use the most? And have you tried them all? And which one did you use the most and why?
So I was working with a huge Reactive Cocoa, Objective-C code base, and all the others I just tried out on pet projects. And at Ustream, we're working with our own implementation, which is closed source. So, but it's really just so what I mentioned. It's very a lightweight, just some signals and operators, like most of the micro frameworks out there. So it's already very helpful.
Cool, thank you. Okay, thank you, Agnes.